Hi, welcome to the video on writing ionization equation practice. So before we get into looking at the practice problems on the first page, I want to go over a couple of key terms. The first key term is dissolving. So dissolving is a process where you mix a solute in a solvent to make a homogeneous solution. So you should remember that a solute would be like something like Kool-Aid powder. That's the thing that gets dissolved. The solvent would be the water, which does the dissolving. And then the solution is the Kool-Aid drink. Now it's called homogeneous solution is because when you look at a solution under a microscope or you look at it with your eye, it will all look the same. You won't see the solute and the solvent separated. It will look like all one thing. So homo meaning the same. Now, many things will dissolve in water, but not everything will undergo the second process, which is ionization. And that's forming ions. So there can be positive and or negative ions being formed. Now, technically, ionization involves removal of an electron to form an ion. However, for the purposes of dissolving, that's not what we're focusing on. We're focusing on things that, when dissolved in water, split apart into cations and anions. And there are two things that can do that. Salts, also known as ionic compounds, and acids. So these molecules, when you dissolve them in water, will split apart into their cation component and anion component. Now, the degree to which they ionize, it's different depending on the substance. So we have what's called complete ionization, where all of the molecules will split apart into cations and anions, and partial, where some of them will split apart and then some of them will stay as molecules. So how can you tell whether or not you have a complete or partial ionization? Well, for ionic compounds, what we do is we check the solubility chart to see if it's a complete or partial. If the salt is soluble, meaning we would notice it as aqueous on our solubility chart, then it completely ionized or splits apart. And if it's insoluble, which we would see as a solid on our solubility chart, it would be partial. So if you look, for example, copper 2 sulfate, if you look at that on the solubility chart, here's copper, and then scrolling over to sulfate, we see that it's aqueous, and so we know that this undergoes complete ionization. So to represent that, we use a single arrow. And so what that's saying is that this copper sulfate molecule here, when you dissolve it in enough water, all of it will split apart into copper 2 ion and sulfate ion. And so we represent it this way in using our formulas there. Now, this is important because what this means is that once this copper sulfate is dissolved in water, all you have are copper ions and sulfate ions. You won't have any of this copper sulfate molecule. On the flip side, on the other hand, copper hydroxide, copper 2 hydroxide, when you dissolve it in water, some of it will split apart into copper 2 plus, and some of it will split apart into and copper 2 plus, and then there's 2 hydroxide ions. But you'll also still have this copper 2 hydroxide molecule in solution. So you're going to have both things in solution. So to represent that, we use these double arrows. For acids, to figure out if it's complete or partial, we use the list of strong acids. So if it's on this list of strong acids, then we know it is complete ionization. And if it's not, it's going to be partial. So let's take a look at this first one here. We have sulfuric acid. You see that on the list there. So we know that's going to be complete ionization. Once again, we're going to use the single arrow to show that all of it has ionized. But there's something different about acids when they ionize. Unlike ionic compounds, where all cations and anions will split apart, for acids, the cation part, which is the H+, also known as our proton, if you have a diprotic acid, something with 2 protons, only one of them will split off at a time. So for a strong acid like sulfuric acid, which has 2 protons, in this case, when we split it apart, we split it apart in H+, and then whatever ion is left, HSO4 minus. Now, how can you tell what's going to be left? Well, you've already you removed an H plus from the molecule H2SO4, so you're going to have one less hydrogen. So instead of H2, you're just going to have just H1, or an invisible one there. And of course, the SO4 comes along. And then you're always going to have a -1 charge. Now, the reason why you have a -1 charge is that the charges must balance. So the positive 1 charge and a minus 1 charge here will give you an overall 0 charge, which is the same that you have on this side. Okay, lastly, for something like a weak acid, hydrofluoric acid, when it splits apart, you're going to remove 1 proton at a time. In this case, since hydrofluoric acid is monoprotic, we are simply going to have just the H plus and the F minus. And of course, since it's partial ionization, as a weak acid, we would use the double arrows. So to take a quick look at a few examples, I won't do all of them. Just want to show you a couple of quick things. We're also practicing some naming rules in these problems. So how do we go ahead and tackle these problems? What I'm asking you to do is for all of these compounds, whether they're ionic compounds or acids, is I want you to split it apart, show the ionization, show this sort of reaction here. And so your setup should always look the same. You should have the molecule, the neutral molecule on the left side. You have to choose the right arrow, and then the cation and anion that it splits apart into. All right, let's start with barium nitrate. So first thing is I need to write the chemical formula. Barium is a group 2 metal, so that means it has a +2 charge. Nitrate is one of my polyatomic ions, and if you look on this chart, you see it, NO3 minus. And so the chemical formula for this is going to be BaNO3 2. I need 2 nitrates and 1 barium, so the overall charge is 0. All right, now that I have that, the next thing I need to do is figure out what arrows am I going to use. As an ionic compound, I'm going to use this chart here. So I look for barium and scroll lower and look for nitrate. It says aqueous, so that tells me it's complete ionization, so I'm going to use a single arrow. And now I'm just going to write down the cations here, Ba2 plus, and my anion NO3 minus. Now, one thing I have to make sure I do, one thing I have to make sure I do as well is I have 2 nitrates here, so I'm going to use a coefficient of 2 to show that this broke apart into 1 barium and 2 nitrates. Similar to what I showed here for the copper hydroxide. It breaks apart in 1 copper and 2 hydroxide ions. So we use a coefficient of 2. All right, let's do one more example with this. So in this case, we have Fe2SO4 I'm not giving the name here, but iron is a transition metal. So if I look on the chart here, here's iron. It's a transition metal. Remember with transition metals, they don't have common charges, so I can't figure out the charge from the chart. So what I have to do is kind of work backwards. What I can figure out the charge of is the sulfate. Sulfate is a polyatomic, so if I look on my polyatomic list, I see it has a -2 charge, and here we go, sulfate is -2. And so, and I have 3 of them, right? I have 3 sulfates. So that means that overall on this side, I have a -6 charge, okay? Because I have 3 sulfates each with a -2. Now, in order for this to be neutral, that means that overall on this side, I must have a +6 charge. So the 2 irons must give me a +6 charge. That means that each iron must be a 3+ charge, since I have 2 of them. All right, now that I have that, I'm going to go ahead and break this apart. So let me just go ahead and rewrite this. Fe2SO4. Okay, let's go ahead now and do the next step, which is to choose our arrow. So we're dealing with iron 3 sulfate. We need to be careful, make sure we're looking at iron 3, because as you can see here, there are 2 irons on this list. So iron 3 is the bottom one. We'll scroll over until we get to sulfate, and here it is. It says that it's aqueous. So once again, I'm going to use a single arrow. If it's dead solid, I would use a double arrow. All right, finally now I'm going to split it apart into the ions. I have iron 3+ as my cation, and I have SO4 2- as my anion, and then I can't forget to write the correct number. So I have 2 irons and 3 sulfates. So I'm going to use this subscript as my coefficient of 2, and then this subscript as my coefficient of 3. Now remember this subscript inside the parentheses, that stays with SO4. SO4 is a group. It stays together. Don't split that apart. Okay. So now that we have that one, let's take a look at a couple of ones with acids. So we went over in class the naming rules for acids. If you look up the acid's name and it does not start with hydro, like in this case there's no hydro, but in here we have hydro. If it doesn't start with hydro, we're going to look on our polyatomic charts list. And nitrous tells me I'm dealing with one of the either nitrate or nitrite. So how do I figure out which one it is? Is it nitrite that this acid comes from or nitrate? Well, the rule goes 8-ic ite us. So if your acid ends in us, it must be an ite acid. All right? And so that means that I'm dealing with nitrite. I'll write that down here. 8-ic ite us. Okay? So since this acid name ends in us, I'm looking for an ite polyatomic, and that would be nitrite. So that means my acid's going to be, since this has a -1 charge, that I have 1 hydrogen with it, HNO2. All right. The number of hydrogens you have are going to correspond to the charge. So this was a -1 charge, I have 1 hydrogen. Okay. Now that I've done that, the next thing I need to do is figure out what kind of arrow I'm going to use. So for that, I will go to my list over here. HNO2, I look on my strong acids list. Oh, it's not here. Nitric acid is, but not nitrous acid. So I have to use a double arrow here because this is a weak acid. All right, and so the cation, when I split this apart, the cation was always going to be H plus. All right, I'm always going to have an H plus, and all of these are all going to have H plus and something else. Like that part's going to be the same, okay, for all of these. All right, so they're all going to have that part. All right, so it's going to have H plus, and then whatever else is left, in this case, it'll be my NO2 minus. Since I removed 1 hydrogen and a positive charge from this, NO2 minus is what's left. It should balance, and if you check on both sides, the charges and the number of atoms balance. Let's do one last example. In this case, let's scroll down to the bottom here. Actually, we'll do these 2 examples together. So let's do hydrobromic next. So in this case, with this name, hydrobromic, notice it starts with hydro. So that means I'm not using the polyatomic, not using this. I would use my periodic table. Bromo sounds like bromine, so this must have come from bromine. And this group has a -1 charge, group 17, so I know it's going to be HBr. Remember, the number of hydrogens I have will equal to the charge. Okay, next thing I need to do to choose the arrow is I will look on the list of strong acids. Boom, here's hydrobromic acid, it's here, so I'm going to use a single arrow. And then I guess it's a little off here. I'll use this information down here. All right, so there'll be H plus, and then what else is left over? Br minus. Okay, so this is all number 3 together. Okay, let's look at H3PO4. So for H3PO4, the thing to remember is you remove 1 hydrogen at a time. So I'm only going to remove 1 hydrogen from here, so just 1 H plus. And then what's left over is going to be H2, PO4 minus. Okay. Real quickly, just to show you what acetic acid, this is acetic acid, looks like. Remember, for something like this, the Cu group, the hydrogen is the hydrogen in the back. So when I split this apart into H plus, I'm going to get CH3COO minus. Okay, so that's pretty much runs through all of the acids. All right, I hope you found this video helpful. And if you have any questions, please shoot me a Schoology message. Alrighty, folks, have a quality day.